So here we go. I am not entirely sure what your comfort level is with functions, but I'm going to use the notation that he gives right here, f of x equals the polynomial. So just to give you a little bit of background, a polynomial is any function that can be written like the following: a x to the n plus a x to the n minus 1, and so on and so forth. You can just keep writing these until you have something like that right there. Okay. Now each of these a's, these coefficients, are different from one another. There are up to n terms. So this means that this is the highest degree, this is the second highest, and so on and so on and so on and so on and so on. This is the second to smallest degree term, and then this is the smallest degree term. So you can have lots of different examples. For example, we have 3x squared minus 2x plus 1. Okay. Now this, if I say f of x equals this, then this guy right here is the leading term because it has the highest exponent. Okay, so the degree of a polynomial is the exponent that is largest. Okay, so if I'm talking about this polynomial right here, f of x equals 3x squared minus 2x plus 1, 2 has the highest exponent value, so the degree of this polynomial is degree 2. Alright? And the coefficients are 3, negative 2, and positive 1. So here's another example. If f of x equals 7x to the 12th minus 5x to the 9th plus 8x to the 8th minus 3x squared, then the degree of this one will be 12. Okay, so you're identifying the largest exponent in your polynomial, and you're identifying that as the degree of your polynomial. Okay, so if we go back to the set of instructions here, it asks you to use the digits of the month, day, and 4-digit of your birth year in order as the coefficients of the polynomial. For example, if your birthday is August 13, 1991, then use 8131991 in that order. So now here's the interesting thing. The degree of your polynomial must be a whole number greater than 2 and less than 6. So we can use up to 4 terms if we want. We can use up to 3. We can use all the way up to 6. Or actually less than 6 is what it wants. Okay, so notice this one has the 8x to the 5th, so he chose a polynomial of degree 5, and he's just putting each digit next to one of these terms in that polynomial. We don't have to be that rigorous, okay? So I'm going to use my birthday really quick and give you an example of what we might choose. So my birthday is 11/26/1983. Okay, so I might choose a polynomial 1x to the 5th minus 1x to the 4th plus 26x cubed plus 19x squared plus 8x plus 3. Okay, so we have a polynomial of degree 5 with the coefficients being just numbers that are pulled out of my birthday. That's one option. So this could be one option. Another option could be 11x, let's go cubed, plus 26x squared plus 19x plus 83. Okay, and so I think I'm going to actually use this one. Notice how small this is. This is really an important point because this is going to allow us to basically come up with a very easy analytical solution to this polynomial. By that I mean, if you come back, once you've decided what your polynomial is, you're going to find the domain and range of it, the y-intercept, all the zeros, describe the end behavior, and the relative minimum and maximum. So this is probably stuff you're not really familiar with. I know I've worked with these three things with you before last year when you're in your other math class. So let's discuss the domain and the range of a polynomial. So here is one fact. Fact 1. Domain and range for any polynomial is domain. We're going to use all real numbers, and I've lost my tool, so hold on a second. Okay, so domain is going to be all real numbers. Okay, now here's the other thing. Let me get rid of this other work here that is unnecessary. So the nice thing about a polynomial of odd degree is that the range is always going to be all real numbers. Okay, so this is very nice. This makes this a little simpler for us to work with. You want to choose a polynomial with odd degree. So in both of these I've chosen 5 and 3. So for the range of this thing, it's all real numbers as well, because the degree is odd. Okay? And that's as simple as it gets. That's fact number 1. So if you choose a polynomial like I have here with degree 3, then your domain and range is all real numbers. And that's as easy as you can possibly get. Now, let's look at your other requirements. So we need to find the y-intercept, and we need to find all the zeros, both imaginary and real. Okay? So the y-intercept is actually easy. The y-intercept is basically when does this polynomial cross the y-axis. And if you're thinking about it, and I hope you are, the only time that a polynomial can cross the y-axis is when the x value is 0. Okay? So we're looking for the point 0 comma something. Well, fact number 2, the y-intercept occurs at f of 0. So what does f of 0 mean? It means evaluate this function when x is 0. Okay, so for ours it would be f of 0 equals 11 times 0 cubed plus 26 times 0 squared plus 19 times 0 plus 83. And obviously each of these terms vanishes because when you multiply by 0 you get 0. So our y-intercept is 83. Okay? So that's pretty much what you need to know for the first 2 parts of this particular problem. Okay? And now we just need to look at the last. Completed domain and range, we found the y-intercept. Now we need to figure out all the zeros, both real and imaginary. Okay, so this is kind of the trickiest part of the whole thing. So we need a new page in order to do that. First things first, let's rewrite our function f of x equals 11x cubed plus 26x squared plus 19x plus 83. Okay? And now here's fact number 3. A polynomial will have at most 3 n solutions for f of x equals 0, where n is the degree of our polynomial. Okay, so if I'm looking at this, the degree is 3, so we should expect there to be no more than 3 solutions when I set this thing equal to 0. Okay, so we actually need to find those, so we're going to say 11x cubed plus 26x squared plus 19x plus 83 equals 0. Okay, and now this is where things kind of get tricky. Okay, so I'm going to recommend that you use a very nice and simple tool for this, and that simple tool is something I like to refer to as Desmos. Okay, so if we go to Desmos.com, and you've used this before, I know you have, and we punch in our function f of x equals 11x cubed plus 26x squared plus 19x plus 83, then I'm going to zoom out, and it turns out this thing only crosses our x-axis once for real numbers. The other times it crosses are in the complex numbers. Okay, so you have to be very careful about how you do this now. All right, a real solution will be x is approximately, what was that? Negative, I think it was like negative, I know it's in here, oh, there it is. Negative 2.7389. Okay, and our complex roots were 0.1876 plus or minus 1.6492. 6492i. Okay, so there's 3 solutions, a real and 2 complex. Okay, now you might be wondering, what is this Wolfram thing that I pulled up? Well, you could just type in your polynomial here and it'll give you the numerical solutions. Unfortunately, any polynomial we come up with, we're probably not going to get an exact solution. And so the only way to do that is by numerical means, which I'm sure you haven't learned, which is why Wolfram Alpha is a nice thing to get your zeros. So just write in your function, write in Wolfram Alpha, and it'll pull up your solutions. The solutions will be listed right here, real root and complex roots. Okay? And that's that. I believe that's all you needed. Let me just double check here. You also need to describe the behavior and the relative extrema. Well, there are extrema in this one, and you can get those just by graphing it in Desmos. But the behavior is that the tail end of the left side of the function goes to negative infinity, the right side goes to positive infinity. So if you come up with a function like I have here and follow all the ingredients that I have, you should be okay to do this. If you have any questions, just text me. Let me know. All right. Take care, bud.